Today I will talk about network analysis using QGIS, and today I will also use some Python codes. So I have explained about network analysis in this website. The link is given in the description. This is the link. So I have talked about network analysis as well as some Python introductory lesson, which means if you follow that lesson, we can move fast and understand what we can do with Python. So we will do some practice exercise. So we will use the data which can be downloaded here. It is data of Kathmandu metropolitan city and surrounding area. You can download any data from any city. So I have given the method. I have explained how can we download the data using OpenStreet Map API. So but I have also given the data already downloaded here, so you can use this one also. So we will practice some point-to-point shortest distance, surface area from points, and we will try to solve some problem using network analysis, like optimum location of firefighters to serve a city. So the example is Kathmandu Valley, and we will use some Python code to automate the process. Let us start. So I have already displayed this road vector data here. So I will select the roads which are important. So I will select by expression, and I have this. So if you see this attribute table, there is one attribute known as highway. So I have used this all the roads which are important. So highway is equal to primary, and these roads we will take. And another one is name. If the road has some name, then we consider it as important, but it can be omitted if you like. So the code is here, and I will select features. So the selected features I will save as for example NW practice, and I keep the name of layer same, and it is projection is 32645, UTM 45 end zone. So okay. I will remove this layer and only keep this layer. So and name I'll make it road clip only. And now let us try to practice some network analysis techniques. So using network analysis we can do these things. So we can find surface area from a point, and shortest path from point to point, point to layer, or layer to point. So I'll not go through all these things. I will show you how to find the shortest path from one point to another, and service area from a point. So by practice we can understand what is the meaning of these two things. So let us first of all try to find the shortest path. So let us open this tool, and road clip is the network and shortest path. So start point, we can just click this button and click somewhere, and similarly we can clip this button and clip somewhere another point, and then run this. So it depends on your on the speed of your computer. So shortest path is displayed here, so we can it is not possible to see here, so we need to change the symbology. So for example, we can keep it black, and so we can see the shortest path from this point to this point. Now let us find the shortest path with some speed. So let us add one uh, attribute with speed. So let us put speed, and we can keep it integer, and I have created one formula to calculate the speed. So this is the case command, and when highway equal to trunk, then speed is 80, and so on. So if you search for case, so you can see that the command is written like this. When condition, then result. So case and end, and when condition, then result. So I have condition and result. So okay. Now we can see that the speed is there. So we save this, and now again use the same location, same 2 points, and try to find the shortest path with speed. So shortest start point uh, we keep it same, and end point also we keep the same, and we speed field we write speed, and then run. So now if we change the symbol of this layer like 1.5, so it is almost the same, but in some cases the uh, shortest path will be different also. So let us now find the service area from point. So let us suppose that we travel 1.5 kilometer from a given point, and then find the area served by this point. So let us select the location of point. For example, we put somewhere, and now if we run this, so maybe it did not run properly. Let us check whether so it could not run properly, so we will try again. Service area from point. So we use this road clip, and then the point is somewhere as you like, any point, and then for example we travel 1500 meter. So we can choose distance or time. So let us try this. So if we zoom to this layer, we can see that from a given point, if we move 1.5 kilometer, then we can reach anywhere along this service area lines. So we can see this. This is the boundary of location where we can reach from the point we selected. So this is the concept of service area. Now let us try to move to the next, solving a problem, optimum location of firefighters to serve a city. So this is the uh, kind of network analysis where we use the concept of service area. So let us suppose that a firefighter can move up to 1.5 kilometer from any given point. So in this example, if the firefighter is located at this point, then we can move up to these locations within 1.5 kilometers. So in this way we try to find all the locations so that we can serve whole the city. So let us remove these temporary layers. So we first of all now we create some nodes. Let us use this V2 points tool and create nodes or points which we can use to locate the firefighters on the road cliff, and let us keep the distance for example say 400 meters. So or maybe 500 meters, and keep it, and then run. So we have created these points, and now we create points which represents the location of firefighter, and then we find the service area and remove those nodes which are served by the firefighter, and repeat this process to cover all the area. So let us suppose uh, in the points we save this point layer in the same geo package nw practice, and we find road nodes. So now so the layer is, so we change this to road nodes. Now I will add two attributes. So I will tell you why I added those attributes. So one is select, and it is boolean, it has true or false values, so make it false. Okay, and one more attribute whose name is removed, and it is also boolean, so it is also false. So till now we have not uh, selected any location of the firefighter. So when we select the location of firefighter, then we make this value true, and all the nodes which are served by this uh, ID we will remove from here. So as a feature it will remain here, but only the attribute will change. So let us try some point. So let us check this first one and zoom to layer. So we can make it a bit better, bigger, or so it is somewhere within this. So we show the FID. So it is randomly distributed. So this is one. So let us say we have selected this layer with value 1. Maybe 1 and 229 is at the same place. So we select this point for service area. So service area from point. So we select this road clip as the network layer, and path type shortest. Start point we keep it 1, and then 1500 meter, and run this. So this is the service area, so let us keep it another color like black. So we can see that the FID1 has served these locations. Maybe this part we cannot go from here, it is not connected. So we remove all the points which has this which are near this service area. So let us select all the road nodes near the service area. So select within distance. There is one. Select within distance. Inside the vector selection. So let us select within distance. So service, we select features from road nodes, service area, and within, for example, it is just attached to the road, so we keep it 1 meter. So let us run. So all the nodes within 1.5 kilometer is selected, and now we change the attribute of the selected nodes. So removed, update the existing, and we select removed and make it true. Okay, and now for the FID one, we have selected the location for this select, so we select this as true. So now let us remove the selection and also save this attribute table, and now we symbolize all the road nodes in different way. So we use category rule based. So if we have selected it as a location of firefighter, then we make it a bit bigger. Label location of so filter, we choose selected equal to, so we need to, because it is keyword, so we need to use double quote, select equal to true, and make it like 10, and we add another one, removed, and we use the filter remove equal to true. Okay, so removed, we keep it uh, almost invisible, and like so make it black or grayish, and keep the size very small, like 0.5. Okay, and another one, uh, level others, so let us keep it like that and apply. So one location of firefighter is selected, and all the removed points are grayed out, and in this way we can choose the next uh, location of firefighter which is not removed among the not served point, and repeat this process until we finally have served all the locations. So I will show you how to do this programmatically. Now we use Python code to automate the steps we followed. So I have listed what we did in this exercise. So first of all, we select a point representing location of firefighter, and set the select attribute to true, and find the service area from that point, and select all points on the service area and set its removed attribute to true, and we repeat above process until few points remain. So we will do these things using Python. So let us first of all set both the attributes to false. So here we have few true attributes, so we keep it false for all and repeat the process again. So first of all, we update the existing, and removed we make it false, and again this we have only one select is true, so we make it false, and then save it. And now we use Python code to follow the same steps. So I have some Python codes. Let us use this expression. So I will tell you what is the expression. So plugins and Python console, and if you write here, so I suppose that you know the meaning of this, so I put it like 1. So we select this point layer, and what is this point layer we have to define. So point layer is this, so point layer is this road nodes, so I change this to road nodes. So point layer will be this, and now we use this code. So we choose where FID equal to 1, and if we run, then the layer with point ID equal to 1 is selected. Now we use this next code. This is point layer, start editing, and this part I will save as some file. So I will create one file. So this is used to show the editor, and I have many files here, so I will create a new file by using this plus. I will remove all the opened file and save this. So PT layer is already defined, so we can use this PT layer start editing, and we select the attribute, so and set the selected attribute to true. So I have written 4 here because the 4th attribute is this select, or maybe 1 0 1 2 3 4 5. So 5th attribute is select attribute, so we use this 5 and then set it to true. So let us do this. We should remember that at this point all the select attribute are false, so it will print the location of this point xy. So let us run this one. So first of all we need to save this. So let us make a folder program and select point.py, and we can run this one. So maybe we need to select again because selection is removed. And then maybe we can run again. So point is here, the xy value of xy is this point, and we use this point to run the algorithm, the service area from point. So these are the parameters we use. So we can check the parameters. So input is the road layer, and start point is the point we have just calculated, and we output as temporary output. So we can choose this and run this part along with this. So xy, 0 of xy and 1 of xy will be the start point, and travel cost we again choose 1500, and outputs will be saved as temporary output, and we will run this program. So before that we need to define this VL. So VL should be like this. Controls. So VL is selected. Now if we run this whole process, then output will be returned, and we can show this output in the map by using this command. So let us try to run all this process. If we run this process, it will take few seconds, and the service area will be the same as before. So we can see that so ID1, there are multiple points with ID is equal to 1, so we get this. So in this case we have to choose FID equal to 1. Anyway, we have successfully run all this process, and now we need to change the attribute of this which are covered by this point to true. So for that, first of all we need to run select within the distance, and again we use the start editing, and we copy this, and we set this is sixth attribute, so I will change this 5 and 6. So first of all we choose this input point layer, and reference as this result is the service area, and distance 1.0, same as the one we run manually. So let us add this part, and then we also add this part for changing the attribute. So let us copy this one and paste to this. We need to keep these tabs properly. So again, because we are going to run whole this process, so we put the value to false again. So let us keep it false, like select also false, and we change the attribute of removed also to false, removed also we make it false. So now save this. Again we run this. So start from here. So we put all the code here. So for example, what is point layer? So point layer is the layer which has this name. Similarly, V layer also we put in the code itself, and then we select by expression, and this time we use FID equal to 1, and save this code. Try to run this code, so it will run all the steps mentioned in this analysis steps. So let us try this. FID equal to 1. So we can now see the process has already completed. So uh, to repeat hold the process multiple times, we need to use this loop. So until the point count is less than 500, which means the removed points is less than 500, we repeat all this process and we select the IDs one by one. So we keep it FID, and then we need to copy this code. So I will keep this code which can be downloaded